Alright, I'm going to talk about waves in two dimensions now. The main thing that you guys need to know about this is that we're going to be dealing with point sources, okay? And for a point source, we're going to assume that that wave spreads out equally in all directions, alright? We have a few things to define here. A wavefront, alright, is a line joining, alright, neighboring points that have the same phase of displacement. In other words, the top of the sine curve here we can assume to be like the wavefront moving forward, okay? The ray is just going to indicate which way the wave is traveling, all right? And rays and wavefronts are perpendicular. At great distances, these wavefronts, okay, you can see here, it's almost like they're a plane wave, okay, completely straight across. That's not always the case, all right? So when we're dealing with power, all right, we're dealing with the energy per time, energy delivered per time. We know that the units are watts. Okay, we've dealt with that before. Intensity is just going to be the power per area delivered, all right? So this is going to be watts per meter squared. Should definitely write this out in the IB way like this, all right? So the total area of energy, okay, is constant, all right? The total energy that's been emitted total area of energy, okay, what ends up happening, the total amount of energy, well actually no, let's go with the total area of energy, right? So the energy itself, excuse me, stays constant, but the total area of energy increases. In fact, it increases in such a way it follows an inverse square law. And that total area is the surface area of a sphere. And that surface area is equal to 4 times pi times r squared. Okay? So as the distance from the source doubles, all right, as r doubles, okay, as r doubles, surface area decreases, increases, sorry about that, by 4 times. And since we're dividing by area, this is the energy per area, okay, intensity decreases by 1/4. All right? So just think of two spheres, all right? One with double the radius. This sphere has a surface area equal to 4 pi r squared. Okay? This surface area, 4 times pi, is double the radius, is 2r squared. If we look at this here, that's 2 squares, we have 4 times as much, so 16 pi r squared, we'll say. Okay? So this guy is 2r, this guy right here is r. Alright? You see that it's 4 times the surface area. Since we're dividing the power with the surface area it's spread out over, okay, that means that the intensity decreases by 1/4. Alright? This is a big idea here. So let's look at an example. A person stands 3 meters away from a 100-watt speaker. Determine the intensity of the sound heard by this person. Well, the first thing that you're going to have to do here, alright, to determine the intensity is to find the area, the surface area. All right, it's going to be 4 times pi times 3 meters squared. All right, when you do this, 4 times pi times 3 squared, there we go. It's 36 pi, all right, which is the same as approximately 113 meters squared. Okay, with that now, we're just going to do power divided by area. Okay, 100 divided by the area here, and that's going to give us 0.88 watts per meter squared, right? And that is the intensity. So the question is, how much energy do they hear every minute? Okay, well, for that part, this is part A. For part B, we're solving for energy, okay? We know power is equal to 100 watts. We know time is equal to 60 seconds. Okay, so to find power, it's just energy, excuse me, it's going to be power times time. 100 watts times 60 seconds. Remember, watts are joules per second. All right, you're going to end up with 6,000 joules. Excuse me, 6,000 joules. There we go. Sorry. All right. And then the final part here, what would the intensity of the sound be if they stood 6 meters away? Well, we've doubled our distance, 2 times the distance. So the intensity is reduced by a quarter, right? So you take your 0.88 watts per meter squared, divided by 4. You should end up with, and you can actually do this calculation by finding the area using 6 meters as your radius, and you should end up with the same thing. All right, so that is it for intensity.